When you design security for artificial intelligence systems, you cannot rely on isolated controls. You need a reference model. You need a layered view. You need a structured blueprint that aligns technology, risk, and governance. Without a reference architecture, every artificial intelligence initiative becomes an experiment. Different teams design different protections. Controls become inconsistent. Risk visibility becomes fragmented. As an enterprise architect or security leader, your responsibility is to define a reusable artificial intelligence security architecture reference model. This model becomes the foundation for safe innovation across your organization. In this session, you will build that layered model. Before you examine individual layers, you must adopt the right mindset. An enterprise blueprint is not a product diagram. It is not a vendor architecture. It is not tied to one cloud provider or one tool set. It is a conceptual structure that defines what must be protected, where controls must exist, how trust boundaries are enforced, how risk is monitored continuously. You are designing principles, not features. Your artificial intelligence security architecture reference model must answer one fundamental question. If artificial intelligence becomes embedded into every enterprise workflow, how do you ensure it remains secure, trustworthy, and governed? To answer that, you build layered protection. Everything in artificial intelligence begins with data. Training data, fine-tuning data, retrieval data, embedding stores, knowledge repositories. If your data layer is compromised, the integrity of the entire system collapses. As an architect, you must consider data layer security from multiple perspectives. Data classification must extend to datasets used for training and retrieval. Sensitive data cannot simply flow into models without governance. You must know which data sources are approved, which require anonymization, and which are restricted entirely. Data integrity must be protected. You must prevent malicious insertion into document repositories that feed retrieval systems. If retrieval augmented generation systems pull from internal knowledge bases, those repositories become critical security assets. Data access control must be enforced. Just because a model can technically access a dataset does not mean it should. Retrieval logic must respect role-based access boundaries. Data lifecycle management must be embedded. How long is training data retained? How is it deleted? How is it version controlled? Imagine a scenario where a malicious document is inserted into an internal knowledge base. If your data layer lacks validation controls, the model may retrieve that content and present manipulated information to executives. Data layer security protects intelligence integrity at its source. Above the data layer sits the model layer. The model represents learned patterns. It encodes reasoning capabilities. It may represent significant intellectual property. Model layer security must address several dimensions. Intellectual property protection is critical. Models may be targeted for extraction through repeated querying. Rate limiting, anomaly detection, and access control mechanisms must be enforced to prevent systematic reconstruction. Confidentiality risk must be evaluated. If a model was trained on sensitive data, you must test for unintended data leakage through inference. Model integrity must be preserved. Fine-tuning processes must be controlled. Unauthorized modification of model parameters must be prevented. Safety guardrails must be embedded. Large language models require constraints to prevent harmful outputs, policy violations, or disclosure of restricted information. From an enterprise blueprint perspective, the model layer is not simply a hosted service. It is a critical asset requiring governance, monitoring, and lifecycle management. Artificial intelligence systems are rarely accessed directly. They are typically exposed through application programming interfaces. The interface layer becomes a major control point. Authentication and authorization must be enforced at this boundary. Only approved systems and users should interact with models. Input validation must be applied. While artificial intelligence systems accept natural language, this does not eliminate the need for validation. You must detect patterns indicative of prompt manipulation or abnormal usage. Rate limiting protects against denial of service and model extraction attempts. Logging and telemetry must be comprehensive. Every interaction should be traceable for audit and anomaly detection. The application programming interface layer is where trust boundaries are clearly defined. External users and systems interact here. If this layer is weak, downstream layers are exposed. Architecturally, you must treat the interface layer as a security gateway, not merely a connectivity channel. Above the interface layer sits the application layer. This is where artificial intelligence systems are embedded into enterprise workflows. This is where a large language model powers a customer support assistant, where a retrieval system supports legal research, where an autonomous agent triggers procurement workflows. Application layer controls must focus on context and behavior. Context isolation ensures that system-level instructions are separated from user input. This reduces the risk of prompt injection. Role-based access control ensures that outputs are filtered based on user privileges. A finance employee should not retrieve human resources data through a conversational interface. Output validation mechanisms ensure that generated content meets policy requirements before being delivered to users. Human oversight checkpoints should be embedded for high-impact decisions. Autonomous execution without review may increase risk. You must design applications with the assumption that outputs are not inherently trustworthy. Validation and filtering become essential architectural components. At the top of your layered model sits governance and monitoring. Security architecture is incomplete without continuous oversight. Monitoring must extend beyond infrastructure metrics. You must monitor model behavior, output patterns, data access trends, and anomaly indicators. Drift detection becomes relevant. If model outputs change significantly over time, investigation may be required. Auditability must be embedded. You must be able to reconstruct how a particular output was generated, which data sources were accessed, and which user initiated the interaction. Governance mechanisms must define which use cases are approved, what risk classification applies to each use case, what regulatory obligations exist, how frequently reviews occur. Incident response plans must incorporate artificial intelligence specific scenarios such as prompt manipulation or data leakage through inference. This layer ensures that artificial intelligence systems remain aligned with enterprise risk appetite and compliance obligations. The power of a reference model lies in integration. Data layer security protects integrity and confidentiality. Model layer security protects intellectual property and reasoning integrity. Interface layer security enforces access control and boundary protection. Application layer controls manage context, behavior, and decision influence. Governance and monitoring provide continuous assurance. Each layer reinforces the others. If one layer fails, another may contain the risk. This is defense in depth applied to intelligence systems. As an architect, you must communicate this layered model clearly to stakeholders. It becomes the blueprint against which every artificial intelligence initiative is evaluated. Consider an enterprise deploying a retrieval augmented generation system connected to internal policy documents. Data layer security ensures that only validated documents enter the repository. Model layer security ensures that fine-tuning processes are controlled and that data leakage tests are performed. Interface layer security enforces authentication and rate limiting. Application layer controls isolate system instructions from user prompts and filter outputs based on role. Governance and monitoring track usage patterns, detect anomalies, and ensure compliance with privacy obligations. When layered architecture is applied, artificial intelligence adoption becomes controlled and scalable. Without it, adoption becomes fragmented and risky. As a leader, your responsibility is not to configure controls. It is to define architecture standards. You must ensure that all artificial intelligence deployments align to a reference model. Architecture review boards assess compliance with the layered blueprint. Security and risk teams are integrated early in design. Governance policies explicitly address artificial intelligence systems. The reference model becomes part of enterprise design authority. This transforms artificial intelligence security from reactive patching into strategic architecture. Artificial intelligence security requires a structured reference model. Layered architecture protects data, models, interfaces, applications, and governance processes. Data layer security preserves integrity and confidentiality. Model layer security protects intellectual property and reasoning integrity. Interface layer security enforces boundary protection. Application layer controls manage context and behavior. Governance and monitoring ensure continuous assurance. An enterprise blueprint mindset ensures consistency and scalability. If this layered reference model resonates with you, then you are thinking like an artificial intelligence security architect. In the next sessions, you will explore deeper design patterns, governance integration strategies, and advanced protection mechanisms for retrieval systems and autonomous agents. Subscribe to the channel so you do not miss the upcoming lectures. Like this video if you believe structured architecture is essential for secure artificial intelligence adoption, and share your thoughts in the comments. Does your organization have a defined artificial intelligence security reference model, or are teams designing protections independently? Let us build secure, resilient, and governed artificial intelligence architectures together.